Hey, hello. I see right now it's just you, Lucas, you and me. So we will start at exactly 1:30, or we will wait a 1 minute or two for people to join. Okay, so you can still relax for 2 to 3 minutes. I'll see you at exactly 1:30. Okay, so it is about time. It's 1:30 already. Wonder why it is just the four of us, the three of us actually. Okay, so we'll wait for 2 more minutes, right? We will start at exactly 1:32. Okay, so it's about time. It's 1:32 now, so we won't be waiting for others. Let's start. Start with the first question with the TMCC paper. So we have 356 plus 29 plus 171 minus 16. So this requires us to use some technique to calculate it faster. So we can do 29 plus 171 first, and then 356 take away 16. Okay, so we have these pairs. They are good friends. They're good number pairs because 29 plus 171 gives us a really nice and neat number, which is 200. I'll write it over here. 171 plus 29 equals to 200. And then 356 minus 16 equals to 340. And because we're doing addition, so that means we will be adding these two numbers together. So it's 200 plus 340, which is 540. So the answer for this question is 540. Oh yeah, sorry about that. I forgot to introduce myself. So my name is Kevin. You can call me Teacher Kevin. I am a teacher at Think Academy, and I teach Year 3 competition class. And also I teach Year 6 mastery and acceleration as well. Right, okay, so let's keep going with question number 2. So find the missing numbers in the sequence below. So let's look at this sequence. We have 6, 15, 12, 13, 18, 11, 24, 9. Okay. So, as you can, if you observe it, you should be able to find, to spot that it is an alternating sequence. So it has two sequences mixed together. So 6, 12, 18, 24 is the first sequence where we are going up by 6 every time. So reasonably, from 24 to the first blank, we'll also be adding 6. So the first blank should be 30. Then let me change the color. So for the second sequence, we have 15, 13, 11, and 9. Then we are going down by 2 every time. So to get to the second blank, we will also need to go to take away 2 from 9, and that will be 7. So the answer for this question is 30 and 7. So it's pretty simple. Let's move on to the third question. If you have any question, by the way, you can note them down, and I will answer them all together at the end of the lesson, at the end of the walkthrough. Okay, so question number 3, count the number of triangles. And it says here, so we have a large triangle. Okay, this is looks like an equilateral triangle, but inside it has been split into smaller triangles as well. So one method of counting it so that we won't make any errors of omission is we first count the triangles made of one piece. You see, altogether we have 1, 2, 3, 3 pieces, right? So we count triangles made of one piece. So we have one triangle over here, one triangle over here, and one triangle over here. So we have 3 of them. And then we count triangles made of 2 pieces. Let's see, how many do we have? So 2 pieces, first of all, we can have this triangle over here. So that counts as 1. Should probably use another color. So this counts as 1. And then another 2 piece, if we combine them, we will have this. But apparently this is not a triangle. It looks rather like a trapezium. So no, we only have one 2-piece triangle over here. Okay, this doesn't count. And then finally, for our 3-piece triangle, it's just a hole. It's just this large one. Okay, change back to blue. For 3 pieces, we only have 1. And then the answer should be all the 3 numbers added together, the sum of them 3. So 3 plus 1 plus 1 will give us the correct answer, which is 5. So we can write, there are 5 triangles in this shape, in this diagram. Right, that's question number 3. Let's move on to question number 4. So one side of a rectangle is 12 centimeters long, while the other is half as long. What does this tell us? Let's draw a rectangle first. So a rectangle is over here. Okay, so according to the question, it says here that one side of the rectangle is 12 centimeters long, and the other is half as long. So we have a long side and a short side. The long side is 12 centimeters, and the short side is half. So it'll be 12 divided by 2. That means it's 6 centimeters. And then the second sentence of the question, a square has the same perimeter as the rectangle. So remember the formula for us to find the perimeter of a rectangle is the length plus the width, bracket, times 2. So it'll be 12 plus 6, bracket, times 2. This is the perimeter of the rectangle, which is 18 times 2, which is 36 centimeters. So this 36 centimeters will also be the perimeter of this square. Okay, let me draw a square over here. Okay. So remember the formula for us to find the perimeter of a square. If the side length is A, okay, or we just use side length to represent side length. So it will be 4 times the side length is the perimeter for a square. And we have found that it is 36. So to find one side, the side length of the square, we simply need to do 36 divided by 4. And we know that the side length, or usually in mathematics, we use A to represent it, will be 9 centimeters for the square. Okay. So for the answer for this question, what is the length of the side of the square? The answer is C, 9 centimeters. All right, let's keep going to question number 5. All the students in year 3 took part in the games held by Think Academy. When the winning students were photographed in a row with Miss Chloe is the 15th from the left and 12th from the right. So let's say Miss Chloe is over here. Okay, she's standing right here. And then there are students on her left and students on her right. So let's just use circles to represent students. And then dot, 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 dot. We don't know how many students there are exactly yet. We will find out. And students on her left, on her right. Okay. And we know that counting from the left to the right in this direction, Miss Chloe is the 15th. And what does that tell us? That tells us that there should be 14 students on her left, right? And then let me change the color to green. So counting from right to left, yeah, it says here that Miss Chloe is 12th from the right. Yeah, so from right to left, she is the 12th. And that means there should be 11 students on her right. Yeah. There should be 11 students. Okay. So excluding Miss Chloe, because Miss Chloe is the teacher, we want to find how many winners are there altogether. So it's basically, we take, let me change the color again. If we take these 14 students and we take these 11 students and we add them up, we find the sum, 14 plus 11, and that will give us the amount of the winners, 25. So there are 25 winners altogether. Okay. Let's move on to the next question, question number 6. There is a bus route, and the bus leaves every 35 minutes. And Andy wants to take the 9:15 bus. He arrives at the bus stop at 9:22. So we have to make sure of one question now, that if he arrives at the bus stop at 9:22, he is not going to make it to, he is not going to catch the 9:15 bus, the 9:15 bus. So that means he'll have to wait for the next bus, which comes, we can find 9:15 plus 35 minutes. We can represent it with we can do this with a column addition. So it'll be 0, because 0 hours and 35 minutes. And that will be 15 plus 35 is 50. So it's 50 minutes. And 9 plus 0 is just 9. So the next bus will come at 9:15. So that means Andy is at the bus stop right now at 9:22. He'll have to wait for how long? For the 9:50 bus. Okay, so then we just need to do another column subtraction. So 9:50 minus 9:22. So for the minutes, we just need to do 50 minus 22, which is 28. And then for the hour, it is 9 minus 9, so it's 0. So 0 hours, 28 minutes is the answer. We don't need to write hours. The question is just asking for minutes. So the answer is 28 minutes. That's question number 6. Let's keep going to question number 7 over here. So 3 cans of juice and 4 cans of coffee are worth 60 pounds together. And the same 3 cans of juice and 1 can of coffee are worth 33 pounds together. So how much is 1 can of coffee worth? Now, let me ask you a question first. Look at these two. We can write down 2 expressions, right? So 3 juice plus 4 coffee equals to 60 pounds. And then 3 juice plus 1 coffee equals to 33 pounds. Now, my question is, if you observe these 2 expressions, what is the same? What remained unchanged? Yeah, and what changed? So the answer to my question should be the juice. The juice remained unchanged. Yeah, the juice remained the same. Well, the coffee changed. I should probably put the red bracket around the coffee. So the juice didn't change. That means it has no effect to the amount of money we pay. Yeah, the only thing that changed here is that we're buying 3 less cans of coffee. And then as a result, we paid 60 minus 33, 27 pounds less. Yeah, so 3 cans of coffee corresponds with 27 pounds less in the amount we pay. So we can write an equal sign between these two. Yeah, that tells reasonably 3 coffee will cost us 27 pounds. Then we can divide the 3 from both sides of the equation. So 1 coffee equals to 27 divided by 3. That is 9 pounds. Okay, which is exactly what the question is asking for. How much is 1 can of coffee worth? It is 9 pounds. So the answer is A. Okay, let's keep going. Question number 8. So which of the following is the sum of 3 consecutive whole numbers? Okay, so let me get back to blue. So we want 3 consecutive whole numbers. Consecutive means that they are next to each other. For example, 1, 2, 3. These are 3 consecutive numbers. 1, 3, 5. These are not 3 consecutive numbers because we are omitting the 2 and the 4. Okay, we are jumping, we're skipping. So that's why, if you have a look, we can represent the 3 consecutive whole numbers with, we can say that the number in the middle is a number. Any number, we don't know yet. But let's just say it's a number. And then because it's consecutive, so the number in front of him, the number in front of this number to the left will be number minus 1. And the number to the right, the number next after it, will be number plus 1. Now my question is, if we represent this number with any number, let's say 3, okay, so this number is 3, and the number in front of it is 3 minus 1, and the number after is 3 plus 1, okay, if we add them up, what will it be? Yeah, this minus 1 and the plus 1, does it have any effect? The answer is no, it will not have any effect. Yeah, the minus 1 and the plus 1, they will cancel out. Because you see, if I write 3 minus 1 plus 3 plus 1, yeah, and then I write on the other side, on the right hand side, 3 plus 3. Will it have any effect? Is it any different? It is not. 3 minus 1 is 2. 2 plus 3 is 5. 5 plus 1 is 6, which is equal to 3 plus 3. So the minus 1 and the plus 1, we can just cancel them out. We just cross them. Okay. So that means the sum of the 3 consecutive numbers we can write as number minus 1 plus number plus number plus 1, and that will be number plus number plus number. Okay, so we have 3 identical numbers adding up, and because you have learned multiplication already, that is equivalent to 3 times the number. Okay, so that means this is the sum. The 3 times number is the sum. Okay, that means the sum should be divisible by 3. Yeah, 3 times 1 is 3, divisible by 3. 3 times 2 is 6, also divisible by 3. So it must be a multiple of 3. Yeah. So we have changed this question into a simpler version. It's just asking you to find the multiple of 3 out of these 4 choices. So is 37 divisible by 3? It is not. Is 38 divisible by 3? It is not. Is 39 divisible by 3? It is. Is 40 divisible by 3? It is not. Okay, so the answer is C. That's the correct answer. And just for your information, because I've told my competition students this, the divisibility rule for 3 is just you take the digit sum of the number. For example, for these 4 2-digit numbers, we have 37. So we take the digit sum, meaning we take the 3 and take the 7. The 2 numbers on the tens digit and the units digit, we add them up, and that will be 3 plus 7, which is 10. And we see if that sum is divisible by 3, if it is a multiple of 3. So obviously, 10 is not divisible by 3. It's not a multiple of 3. So no, 37 is not divisible. And then as for 8, we have 3 plus 8. The digit sum is 11. And 11 is also not divisible by 3. So no, B is not a multiple of 3 as well. And for 39, 3 plus 9 is 12. 12 is a multiple of 3. So that means C is divisible. Yeah, so we can represent it as 39 equals to 3 times 13. And then we know that number should be 13. So we can write these three consecutive whole numbers as 12, 13, and 14. And if you add them up, you will see that the sum is 39. Yeah, C. Okay, and then for D, 4 plus 0, which is just 4. And obviously, it is not divisible by 3. Yeah, and this is question number 8. Let's keep going to question number 9. So Cindy asked her grandfather about his age. Her grandfather replied, you add 10 to my age, divide the sum by 4, subtract 15 from the quotient, and multiply the difference by 10. You will get 100. So it looks like this is an age problem on first look. But if you look at what the grandpa said, it is actually a number machine problem. And with number machine, it is always helpful if we draw a diagram. Okay, so let's start from grandpa's age in a box. We don't know what it is, so we just leave the box empty, and we add 10 to the age. So we add 10 to the box, and we'll get another number. Let's just say another box, okay, a new number, and then this is the sum. We divide the sum by 4. Okay, we divide it by 4. We get the quotient. Then he said, subtract 15 from the quotient. Now we get a difference, and we multiply the difference by 10. Now, what will we get? We will get 100. Okay. So now, if a number multiplied by 10 is 100, how should we get that number? Yeah, how should we do the reverse operation? The answer is pretty simple. The reverse operation is just divide 100 by 10. Yeah. If we multiply by 10 to get 100, then to get the box, to get the number in the box, we simply do divide by 100. And similarly, to get the number after being subtracted 15, we simply add the 15 back. Okay, so 100 divided by 10 is 10. We write it in red. So it's 10 in this box. And then for here, we should have plus 15 in the opposite direction. And then divided by 4 in the opposite direction will be multiplied by 4. And plus 10 in the opposite direction will be minus 10. Okay, so let's do reverse calculation. 10 plus 15 is 25. 25 times 4 is 100. And 100 minus 10 is 90. So the number we're starting with, the grandfather's age, is 90. Yeah, Cindy's grandfather is 90 years old, which is really long living. Okay, so let's keep going to question number 10. So we have a number puzzle over here, a column addition number puzzle. So some of the digits in the following correct addition problem have been replaced by the letters P, Q, R, and S as shown. How much is P plus Q plus R plus S? So let's have a look. So usually with these puzzles, we always start with the units digit, with the units column. So we have 5 plus S equals to 4. Yeah. So 5 plus some number becomes something less than itself. Is it possible? It's not, unless S is a negative number. But right now, we are not considering negative numbers. Okay. So it must be the carrying situation. Yeah. We must be carrying a digit to the tens digit. Yeah. So it must be 14 instead of 4. So this is correct. 5 plus S equals to 14. And reasonably, S will become 14 minus 5, S equals to 9. Okay. There's 9 over here, and then we carry a 1 to the tens digit. I'll write the 1 on top, plus 1. So for the tens digit, we have 4 plus 1 plus R equals to 5. Now, again, we have to consider if we are carrying or not. Yeah, 4 plus 1 plus R, that is 5 plus R equals to 5. So this is the first situation where we're not carrying. Now, how about if we are carrying? So 5 plus R, yeah, equals to 15. Is it possible? Yeah. Well, there should be some more restriction in this question. Like, for example, like P, Q, R, S are all positive whole number. Yeah. That has the range 0 to 9. Yeah, that would be reasonable. Because, yeah, and also for column addition, it is reasonable as well. We cannot have 10 for column addition. Yeah, for column addition, each number must be a 1-digit number. Yeah, 10 is a 2-digit number, so it doesn't work. So we cannot have 5 plus R equals to 15, because that way R will be a 2-digit number, so we don't consider this situation. So 5 plus r is just 5, and 5 only. That means r equals to 5 minus 5. R is just 0. Okay. And then finally, this is the only tricky part for this question. We have p plus q equals to 6, but we cannot determine what is the exact value for p or q. But on second thought, we don't have to, right? We're looking for the sum. The question is not asking you what is p, what is q, what is r, what is s. It's asking you for p plus q plus r plus s. So we know from here that since we're not carrying one digit, we're not carrying any digit from the 10th digit, so p plus q is just 6. Okay, p plus q is 6. And we have got over here r equals to 0, s equals to 9. So reasonably, p plus q plus r plus s equals to, this is 6, this is 0, this is 9. So there'll be 6 plus 0 plus 9, which is 15. So the answer is B. Okay, that's question number 10. Let's keep going to question number 11. So Kitty always makes one large jump followed by 2 small jumps on the number line, as shown in the picture. So one large jump is 2 units from 0 to 2, and 2 small jump, each small jump is 1 unit, yeah, from 2 to 3 and then from 3 to 4. So Kitty starts at 0 and ends on 64. How many times does Kitty jump? So we can draw, we can complete drawing for Kitty's jump. It actually looks like a kangaroo, but never mind. So one large jump, then one small jump, one small jump. See, this is a group. Okay, this is a cycle. I should probably use another color. So one cycle is 4 units with 2 large jumps and with 1 large jump and 2 small jumps. This is cycle number 1. And then cycle number 2 is from 4 to 8, again with 1 large jump and 2 small jumps. This is cycle number 2. So it is our job to determine how many cycles are there from 0 to 64. And we know that there are 4 units, yeah, or 4 numbers in each jump, in each cycle. So how many 4s are there in a 64? We do division, 64 divided by 4, which is 16. So we know that there are 16 fourths. Yeah. In other words, there are 16 cycles. You have 16 of these groups in a 64. And we know that in each group, Kitty is jumping 3 times, right? 1 large jump plus 2 small jumps. So 16 groups. In each group, it is jumping 3 times. So we multiply 3 to the 16, which gives us 48 times she is jumping. So 48 is the correct answer. Yeah, it should be C. C is the correct answer. Okay, let's keep going to question number 12. So 5 children ate some plums. Lucy ate 2 plums more than Sophie. Betty ate 3 plums fewer than Lucy. Claire ate 1 plum more than Betty and 3 plums fewer than Alice. The question is, which 2 girls ate the same number of plums? So we have 3 sentences over here, and it tells us 3 useful information. So from sentence number 1, we can write the expression Lucy equals to Sophie plus 2, because Lucy ate 2 more than Sophie. Yeah, and from the second sentence, we can say Betty ate 3 plums fewer than Lucy. So Betty equals to Lucy minus 2, because it's, sorry, not minus 2, but minus 3, because it's 3 plums fewer than Lucy. And then if we want to have Lucy on the same side, we can write, we can put the minus 3 to the other side of the equation, which will become Betty plus 3 equals to Lucy. Okay, so I will erase these 2 and write the new equation. Don't worry if you're not at all comfortable with this. I will introduce another method later on. So Lucy, from the second sentence, we know that Lucy equals to Betty plus 3. Okay. Now the third sentence tells us that Claire ate 1 more plum than Betty. So Claire equals to Betty plus 1. Now I know that the third sentence also said that 3 plums fewer. Claire ate 3 plums fewer than Alice. But do we care about Alice? Alice is useless information. It's not going to help us getting anywhere. So no, we don't need to care about this sentence. Okay. And then there is a hidden information in this question that needs you to observe expression 1 and expression 2 carefully. Yeah, it tells you the relationship between the number of plums eaten by Sophie and Betty. Okay. So because Lucy equals to Sophie plus 2 and Lucy equals to Betty plus 3. So we can actually write Sophie plus 2 equals to Betty plus 3. This is the hidden condition. Okay, this is the hidden information, which is equation number 4. Yeah, expression number 4. So if we take away 2 from both sides of the equation, so Sophie plus 2 minus 2 equals to Betty plus 3 minus 2. So we can write Sophie, yeah, plus 2 minus 2 cancels out, equals to Betty plus 3 minus 2 gives us plus 1. Yeah. Now it is clear. It is crystal clear, right? The question is asking for which 2 girls ate the same number of plums. So it should be Claire and Sophie because they're both Betty plus 1. Okay, so the correct answer is B, Claire and Sophie. Now, if you are not at all comfortable with this method, there's another method you can use, which is much simpler, which is called assigning numbers. So you can assign. So again, you have to write these relationships down, and you can assign numbers to Lucy. For example, you can let Sophie to be you can let Betty to be 1 because Lucy equals to Betty plus 3. Okay, so we let Betty to be 1. Looks like Betty is the smallest. So Betty is 1. Let me change the color. I'll assign green. So Betty is 1, and then Lucy will be 1 plus 3. So Lucy will be 4. If Lucy is 4, then Sophie has to be 2. Okay, and then Betty is 1, so Claire is 2. And then yeah, I know it doesn't make sense because it says Claire ate 3. Oh, yeah, it does. It does make sense. So Betty ate 3 plums fewer than Alice, then that means Alice will equal to Claire plus 3. So 2 plus 3, Alice ate 5 plums. But it's not going to help us knowing how much Alice ate because the question is not asking about Alice. So again, you can see that from this method, you can also see that Sophie and Claire ate the same number of plums, 2 plums. Okay, so again, correct answer is B, Claire and Sophie. So let's keep going to question number 13. This question is a bit hard. So let's see, a black square plus a black square equals to an apple. A black square minus a black square equals to a banana. A black square times a black square equals to grape. And a black square divided by a black square is equal to a strawberry. So no matter what the black square is, 2 of the fruits have already pinned down. Okay, we already know the exact value, which is the banana and the strawberry. So no matter what number you have, yeah, so a number minus itself will always be 0. Okay, you can think of any number. 100 minus 100, 1,000 minus 1,000, 6 minus 6, 2 minus 2 is always 0. Yeah, and similarly, yeah, so we know that banana is a 0. And similarly, any number divided by itself, yeah, 100 divided by 100, 1,000 divided by 1,000, 6 divided by 6, 2 divided by 2, it will always be 1. Yeah, I will change the color. So if we're going to divide, it's always going to be 1, right? 1. So the strawberry is going to be 1. So we have banana is 0 and strawberry is going to be 1. So what's left for us is just to determine the apple and the grapes. And the hard part for this question is that at the current stage in grade 3, you don't have the enough knowledge supporting you to find the exact value of apple and grape. Okay, I will tell you how to find the exact value for apple and grape for the black square, but I will also tell you how you can solve this problem using trials. Okay, we plug in some numbers and we see if it is the correct answer. Right, so let's have a look. So square plus square, a number, 2 identical numbers plus added together, that will be equivalent to square times 2. So the apple is square times 2. Yeah, we can also represent it as, yeah, so it's just square times 2. And then for grapes, we have square times square. So apple plus grape equals to square times 2 plus square times square. Now, this requires knowledge called find common factor, which is the same number that we are multiplying in these two expressions, square times 2 and square times square. Okay, some of you might know, some of you might not, but I'm just going to introduce this to you. So we take out that common factor, meaning we take out that common number we're multiplying. We take the square out and multiply. Whatever's left, put it in a bracket, 2 plus square. Okay, the top, yeah, this equation, this expression is equivalent to this expression. Okay, these two are equivalent, they're equal. So we have square times square plus 2 equals to, so this is an apple plus a grape, and that we know is equal to 15. Why? Because the banana is 0, so we can just throw it away. It has no effect to the sum. But the strawberry is 1, so we need to take away the strawberry. Yeah, so it should be 15. So plus 1 equals to 16, right? So this is 15. Okay, so an apple plus a grape, a square times bracket square plus 2 equals to 15. And then we will need to split 15 into factors. Yeah, 15 can be split into 1 times 15. Can we have 2? No, 15 is an odd number, so it doesn't have any factor. It doesn't have a factor 2. 3, it has factor 3. 3 times 5. Yeah, and then 4, no. 5, yes. 5 times 3. But you see, we'll just be repeating ourselves. So the next one will be 15 times 1. Again, it is okay if you're not at all comfortable with this method. Yeah, it is beyond level of grade 3. Yeah, but I will show you how we solve this using trial. Okay, so we have 3 and 5. You see, it corresponds with square and square plus 2. So that tells us square should be 3. Yeah, 3 times 5 is 15, and square plus 2 is the 5. So square is 3. That is the answer for this question. And if you want to check, square plus square is square plus square is 3 plus 3, which is 6. Square minus square is 0. Square times square is 3 times 3, which is 9. And then square divided by square is 3 divided by 3, so it's 1. And then it's 6 plus 9 plus 1, so it's going to be 16. No problem. Now let's see how we can solve this problem using trial. So using trial at this grade level, at grade 3, we always start with 1, the smallest number we can have. Yeah. It's meaningless using 0 because 0 plus 0 is 0. 0 minus 0 is 0. 0 times 0 is 0, and 0 divided by 0 is not defined. So no, not 0, but we start with 1. So square plus square, if it is 1, we will get 2. Square minus square is always 0, no doubt. Square times square is 1. Square divided by square is 1 as well. And if we add these 4 numbers together, we will get 4, not 16. So no, square is not going to be 1. How about 2? Let's try 2. Square plus square is 2 plus 2, so it's going to be 4. Square minus square is 0. Square divided by square is 1. Square times square is going to be 2 times 2. It's also 4. And if we add these 4 numbers together, it's going to be 4 plus 4 plus 1, so it's 9. Also not 16. So no, square is not going to be 2. Now, what if square is 3? So if square is 3, square plus square is 6. Square minus square is 0. Square times square is 3 times 3, so it's 9. And then square divided by square is 1. So if we add these 4 numbers together, it's going to be 9 plus 1 is 10. 10 plus 6 is 16. So 16. Okay, good. So that means square is equal to square equals to 3. Okay. So that is how we solve question number 13. Let's move on to question number 14. So Chris sticks 7 centimeter long sticky notes together and gets a 337 centimeter long paper strip. The length of each overlapping part is 2 centimeters. How many sticky notes does he use? So for this type of question, the easiest way is to draw a clear diagram. Okay, draw a clear diagram. If your diagram is not clear, it will also give you a hard time. finding the correct answer. So let me draw a sticky note. Okay, and the question told us it's 7 centimeters long. So I'll mark it over here. And then a second sticky note overlaps 2 centimeters with the first. Like this. So I will draw it in another color just for you to see it more clearly. With green. This is my second sticky note. Okay. Now this overlapping part, I know is going to be 2 centimeters. And because my second sticky note is 7 centimeters, and that means this part, okay, this part was not overlapped, should be 5 centimeters. Yeah, and the same for the first one. This part should be 5 centimeters. Okay. Then for the third sticky note, here's the tricky part. The third sticky note, it overlaps 2 centimeters on the second sticky note as well. Okay, so it's 2 over here. There are lots of numbers. It might look a bit messy, but it's okay. I will erase some numbers later on. Just show you the numbers we should be focusing on. And this is 5 centimeters because a sticky note is 7 centimeters long. No problem. But remember, we are still going to overlap and overlap and overlap. So the part that is not overlapped for a sticky note right in the middle, okay, the part that's not overlapped, I will mark with red. It's going to be 3 centimeters over here. Yeah, this is the part that is not overlapped. Let me draw another sticky note, a fourth sticky note, with yellow, perhaps with orange. Okay, so this sticky note, this is the fourth sticky note, and similarly, it's going to be 3 centimeters over here. Okay. And so on and so on. So I won't keep drawing. It's going to take a lot of time if I keep draw all the sticky notes all the way to 337. Okay, but let's just say that the last part is also overlapped. Yeah, but I'm just not going to draw the last sticky note. Okay, so let me erase some numbers and everything will be clear for you. I will erase the 7 centimeters. This is gone. I'll erase the 2 over here and the 5 over here. The 5 over here. Okay. Now, this part, for the last sticky note, oh, sorry, I shouldn't do that. Let me get them back. Yeah, this 7 centimeters should be gone. That is no doubt. Then this 2, I should probably write the 3 on the other side. Okay, I'll write the 3 on the other side. This 5 centimeters will be gone. This is a 3. This is a 2. I'll write them all on one side just for you to see it clearly. This is a 2. The 5 centimeters will be gone. And this is a 5. So this is 5. But I won't represent the last sticky note. Let's just say this is the last sticky note. I won't represent it with 2 and 5. I will just represent it with 7. Okay, so for the last sticky note, there is no overlapping parts. Okay, so the most tricky part of this question is now done. Okay, we just need to draw a clear diagram and mark the clear numbers on it. So we have, let me just combine the 2 and 3 together, and they will be 5. This is 5, and this is 5. Okay, so we have 5, 5, 5, 7. That is when we have 4 sticky notes. Okay, so for 4 sticky notes, we have 5. Let me change the color. we have 5, 5, 5, 7. And if I add one more sticky note, if we have 5 sticky notes, we will have, I need to draw another sticky note over here. So this 7 becomes a 5. This part here will be 5 cm, and this will be 7. So you see, for 5 sticky notes, we will have 5, 5, 5, 5, 7. And as for 6 sticky notes, I'm sure by now you have already found the pattern. For 6 sticky notes, it will be 5, 5, 5, 5, 5, 7. So only the last term will be a 7. Yeah. And so by now, if we want to find the sum, yeah, we know that the sum is 337 centimeters. If we want to find the sum, one easy way is that you see here, the 7 is the only thing that's different from all the other terms, yeah, from all the other numbers. Everything else is a 5. Only the last one is a 7. So why don't we change it into a 7, right? If we change, why don't we change the 7 into a 5? And that will make calculation super easy, because if we have, for this example, if we have 4 5s adding together, it will be equivalent to 5 times 4. Yeah, the sum will be 20. And to find how many sticky notes there are, we simply need to take the sum, 20, and divide by 5. That will give us immediately there are 4 sticky notes used. Similar for this, similar for the second one. If we take away 2, yeah, we change the 7 into a 5, means that we're taking away 2 from the sum as well. You see, before we have 5 plus 5 plus 5 plus 7, the sum is 22. But now we have 5 plus 5 plus 5 plus 5. We're taking away 2 from the 7, and we're taking away 2 from the sum as well. It is 20. Okay, we need to take away 2 from both sides of the equation. And for the second one, 5 plus 5 plus 5 plus 5 plus 7, this is 27. And if we take away 2, yeah, let this become a 5. And on the other side, on the right-hand side of the equation, we will have 25 as well. Yeah, so we have 5 5s added together, that will be 25. And if we divide by 5, that will tell us we have used 5 sticky notes. Okay, similar for the last one. Okay, 5 plus 5 plus 5 plus 5 plus 5 plus 7, that will be 32. Okay. And if we take away 2 from 32, that means we change this 7 into a 5. So 32 minus 2, divide by 5, that will tell us instantly how many sticky notes we have used, which is 30 divided by 5, so it's 6. Okay, and then we can use this pattern we got and do that same operation with this 337 sum. So 337 minus 2. Okay, now we have make all of these sticky notes 5 centimeter long, and then divide by 5. And that will be 335 divided by 5. This is simple division. You should be able to do this on your own. So the quotient is 67, and that tells us we have used 67 sticky notes. Okay, that's question number 14. Whew. Oh, so that's been a very long session. Let's have a look at the last question. Question number 15. I can buy cupcakes at 3 for 5 pounds and can sell them at 2 for 5 pounds. How many cupcakes must I buy and sell in order to make a total profit of 30? So to find the answer for this question, we need to be clear of the concept of profit. So profit equals to cost minus gain. Okay, so the cost is the amount of money spent on cupcakes. Yeah, the amount of money you spent to buy the cupcakes. Yeah, and then the gain is the amount of money you obtained. Yeah, the amount of money you gained by selling the cupcakes. So usually, it should be the other way around. It's gain minus cost, because usually the gain should be more than the cost. Otherwise, you're losing money, which we don't want. So it should be gain minus cost. Okay, so for businessmen, we want to maximize our profits, meaning that we either want to have more gain, or we want to decrease the cost. Yeah, minimize the cost. But that is irrelevant with this question. So let's see, for this question, we need to find, first of all, the gain and then the cost, so that we can have a total profit of 30. So let's see for one cupcake. Okay, so for one cupcake, what is the profit? That means we need to find the cost for one cupcake, and we take it away from the gain of one cupcake. And we do that by doing division. So we know that to buy 3 cupcakes, we need to pay £5. So for one cupcake, so 3 divided by 5 will give us the cost, how much we pay for one cupcake, which is 3 over 5. Oh, sorry, should be the other way around. We paid £5, and we bought 3 cupcakes. We divide by 3, so one cupcake is 5 over 3 pounds. This is 1 per cupcake. And then for selling, for the gain, we are doing £5 for every 2 cupcakes. So 5 divided by 2. That means we are gaining, we are getting 5 over 2 pounds per cupcake. So we plug, this is the cost, and this is the gain. We plug these two back into the equation, and that tells us the profit for one cupcake is 5 over 3 minus, 5 over 2 minus 5 over 3, which should be, so if we find the common denominator, which is 6, so this will be 6 over 15 minus 15 over 6 minus 10 over 6. That will be 5 over 6. Okay, so this 5 over 6 pounds is the profit for per cupcake, for every cupcake. Okay. Right now, what I'm saying is method number 1. I will show you how to do it in method number 2. Okay. So for method number 1, the final step is we want the total profit to be £30, and we know that we make 5 over 6 pounds for every cupcake. And then how many cupcakes do we need? We simply do division. So it's going to be £30 divided by 5 over 6. It's going to be 30 multiplied. Remember, divided by a fraction is multiply the fraction turned upside down on its head. And turn the fraction on its head and multiply instead. It's going to be 30 times 6 over 5. And we can cancel out the 5. 5 goes. And what's left for the 30 is just 6. The 6 times 6 is 36. So the answer is 36 cupcakes. I need to buy 36 cupcakes and sell them in order to make a profit of 30 pounds. So the correct answer is D. That's method number 1. Let me clear the board and show you method number 2. So for method number 2, because we are dealing, so for one cupcake, we're dealing with 5 over 3 pounds, which is impossible in real life, right? We cannot have a fraction. We don't have a note. We don't have money to pay in fraction. So that means we want the number, we want the money to be in a whole number. And to do that, it means that if we can only pay a whole number of 5 pounds when we're buying 3, then we can only buy cupcakes in groups of 3. Think about that. That means we are buying, the amount we buy will be a multiple of 3. Okay? So 3, 6, 9, 12, 15, etc., etc. Okay? So if we buy 3 cupcakes, we're going to pay 5 pounds. If we buy 6 cupcakes, we're going to pay 10 pounds. If we buy 9, we're going to pay 15. And if we buy 12, we're going to pay 20, etc., etc. Okay? And then, if we're going to sell them, we say it's the same thing. For the customer, it's going to be they buy 2 cupcakes for 5 pounds. Okay, it's the same thing. They can only buy, or we can only sell them in groups of 2. Because if we sell them in a group of 3, it's going to be we're going to need a fractional money from the customer, which is impossible. We don't have fractional money in real life. We only have 5 pounds, not 5 over 3 pounds or 5 over 2 pounds. Okay. Actually, we have 5 over 2 pounds, which is 2.5 pounds. It's going to be 2 pounds and 50 pence. But for this question, let's just say we only want whole number money. Okay. So that means the number we buy, the multiple of 3, should be a multiple of 2 as well. And that is a really important concept, which is lowest common multiple. Okay, not lowest common multiple, just common multiple for this question. So we'll need to find the common multiple of 3 and 2. The lowest common multiple of 3 and 2 is 6. I can just tell you, okay? Because if you want to understand why, I can tell you, because 3 and 2, they are coprimes. Yeah, they are consecutive numbers, and consecutive numbers are coprimes, meaning they have no other common factors other than 1. Then to find the common multiple of two coprime numbers, you just simply multiply them together. 2 times 3, you get it. The common multiple of 2 and 3 is 6. So if we buy 6 cupcakes, it cost us 5 times 2, so 10 pounds. This is the cost. And how much do we gain? We sell the cupcakes in groups of 2, and we're going to sell 3 groups of them. So 3 times 5 is, we will gain 15 pounds. We will get 15 pounds. So the profit is going to be gain minus cost, 15 pounds minus 10 pounds. The profit is going to be 5 pounds. Okay. So what does that tell us? That tells us, so for every 6 cupcakes we sell, we buy and sell, we will have a profit of 5 pounds. Then, if we want to make a total profit of 30 pounds, we simply need to do 30 divided by 5, and that tells us we need 6 groups of cupcakes. Yeah, this is one group with 6 cupcakes. And we need 6 groups of them, and each group containing 6 cupcakes. So the total number of cupcakes we need to buy and sell is 6 times 6, 36 cupcakes. So the correct answer is D. Okay. Right, those are all 15 questions for the TMCC paper. Do you have any questions? If you have no other questions, you are free to leave. Okay. And I will see you next time. Yeah, and I will stop sharing and end the meeting.